2018 NAT one more question. So the valency of iron in hematite. So hematite is a formula of Fe2O3. So here the valency of iron is 3. So it is ferric iron. So the absolute difference in more hardness value of the two silicate among the mineral listed below. So here among these minerals, all are belong to more scale hardness, from which talc and topaz are silicate. So talc, it has a hardness of 1, topaz has hardness of 8. So the difference between them is 8 minus 1, it will be 7. So in the Garnet formula, Fe 2.5 Mg 0.3 CaX Al2 Si3O12. So X represents the number of atoms of Ca. So we have to calculate the mole percent of grossular in the garnet. So in general formula of garnet, it is X3Y2 Z3O12. So this X place they will add up to 3. So here it is given Fe 2.5, only in the X place I am writing Mg 0.3 and CaX. So Ca will be 3 minus 2.5 plus 0.3. So it will be 0.2. It will be Fe 2.5 Mg 0.3 Ca 0.2. So we have to calculate the mole percentage of grossular, which grossular has a composition of Ca 3, Al2, Si3, O12. Here it is not 3, it is 0.2. So what will be the percentage? If it is 3, it is 100%. So now it is 0.2. So we have to calculate the percentage of 0.2 of 3. It will be 0.2 into 3 by 100, 0.2 by 3 into 100 will be 6.6%. Answer will be 6.6%. Then comes to 2 marks. Based on 8 oxygen atoms, the number of silicon atoms in plagioclase composition albite 20, anorthite 80. So albite 20, anorthite 80 means you can write down the formula like this. Albite is sodium, it will contain 0.2, anorthite is 0.8. The anorthite is 0.8. So we have to calculate the number of silicon atom. What will be the silicon atom? Silicon atom we have to calculate. We have also Al here, O8. So if you know the composition of albite, that is NaAl Si3O8. So when sodium is 1, silicon is 3. Now here sodium is 20%, that means albite is 20%. So silicon, for albite silicon will be 3 into 20%, that will be 3 into 0.2 is 0.6. Then for calcium or for anorthite, you can say the formula is CaAl2 Si2O8. So when calcium is 100% or 1, Si is 2. So here calcium is or anorthite is 80%. So it will be 2 into 80%, 2 into 0.8 will be 1.6. So when Na is 0.2, Si will be 0.6. When An is 0.8, it will be 1.6. So the silicon will be 0.6 plus 1.6. It will be 1.6. or sorry, it will be 2.2. It will be 2.2. So the value of silicon will be 2.2 here. Then also a diamondiferous lamproite is ultra potassic as molar ratio. So here molar ratio of K2O and Na2O is given. It has a ratio of 11. So if the Na2O content it is given 0.62 weight percent, and the K2O content we have to find out. So K2O weight percent we have to find out. So first the molar ratio is given here 11. So first we have to calculate the moles of Na2O. So what will be the moles of Na2O here? Moles of Na2O. It is given mass by molar mass. So given mass it is your 0.62 divided by molar mass. It is given Na2O has 61.98. From that we can calculate the moles. So 0.62 divided by 61.98, it will be 0.01. So Na2O is present 0.01 mole. So ratio is given here K2O by Na2O, it is given 11. So from which we have Na2O 0.01. Then we can calculate the moles of K2O. So it will be 11 into 0.01. 0.01 will be 0.11. So now we have 0.11 moles of K2O. So moles of K2O is 0.11. Then we'll move to the same formula, given mass by molar mass. So the moles of, you can say the moles of K2O will be given mass that we have to calculate, and molar mass is given 94.02. Moles is 0.11 into 94.02. It will be your weight percentage or given mass. 0.11 into 94.02. It will be 10.34. The answer will be 10.34. Next, 2019 NAT 1 mark question. The radii of A2 plus and B minus ion are given. As you can say, radius of cation and anion is given. It is 1.12 angstrom. That is radius of A2 plus 1.12, that is cation, and anion is given B minus, it is 1.31. So we have to calculate the coordination number. So coordination number is equal to radius of cation by radius of anion. So radius of cation is 1.12, radius of anion is 1.31. So 1.12 divided by 1.31, it will be 0.854. So for this question you have to remember the radius ratio, and from that you will know the coordination number. So if the coordination number is between 0.732 to 1, then the coordination number is 8. So this ratio it fall between 0.732 to 1. So the coordination number will be 8 here. Then a light ray passes from a mineral A to mineral B having refractive index 1.750. We will do this like this. So light ray, it is passing from mineral A to mineral B having refractive index. Here refractive index is given 1.750. Here it is given 1.430. So light ray will pass like this. So this is incident angle. This is angle of refraction. So the limiting value, the angle of incident above which the light will undergo total internal reflection. So it is given for total internal reflection. So for total internal reflection, the angle of refraction will be 90 degrees. So this will be angle of refraction. So it will be equal to 90 degrees. In that case, the incident angle is called critical angle. So we can calculate the critical angle C by this formula sin inverse N2 by N1. So sin inverse N2 is 1.430 divided by 1.750. So it will be 54.79. So the critical angle for which the light will critically refracted, it will be 54.79. Then the difference between SIO ratio of K feldspar and olivine is. So K feldspar, it has a formula KAL Si3O8. It is K feldspar, and olivine, it has a ratio. It has a formula. You can take Mg Fe SiO4. So it is olivine. So here the ratio of SiO, it will be 1 by 4, 0.25. Here ratio you can take, because this aluminum, it takes the place of silicon, it replaces the silicon position. So you can take 4 silicon divided by 8, it will be 0.50, where the difference between them will be 0.25, or else you can take the ratio 3 by 8 also. This will be also correct. It will be 0.375 and the difference will be 0.125. So any of these two will be correct. Then if a crystal contains 5 faces and 8 edges, the number of vertices. So it is from Euler's theorem. So face plus corner equal to edge plus 2. So I have to remember this formula: face plus corner equal to edge plus 2. So 5 faces, and we have to calculate the corner, that is vertices, equal to 8 plus 2. So corner will be 5. Now the core and ring composition of garnet are given. So core ring composition, it is given Fe 0.75, Ca 0.90, Mn is given 1.35, Al2, Si3O12. This is one core composition, and rim composition is given Ca 1.35, Mn 0.75, and Fe is given 0.90. So here we have to calculate the difference in mole fraction of spessartite. So spessartite is Mn bearing, Mn3, Al2. So from Mn3, how many fractions are present here? Here 1.3 present, here 0.75 present. So I have to calculate the fraction. So this is your core, this is your rim. So first we'll calculate the fraction in core. It will be 1.35 by 3. Then fraction in rim will be 0.75 by 3. So core fraction will be 0.45 and ream fraction will be 0.25. The difference will be 0.